So welcome back to my channel. Here in this video we will solve one LeetCode problem, that is 958. Check completeness of a binary tree. Here I'll start with describing the problem statement. What it says: there is given a complete binary tree. I had told in my previous videos what is a complete binary tree. I'll still repeat that a complete binary tree is a tree where every level is filled. Every level is filled except last. And additionally filling is done from leftmost. Okay, I'll tell. So this is a complete binary tree. Okay, we'll hide the last level. We'll not look at the last level. First we'll see before all the levels above the last level. This, okay, we'll see that does every node have two child? Yes, it has. We'll not see over here. All the level above the last level should be filled. Yes, it is filled. Now in the last level we'll see that nodes should be from the rightmost. Yes, it is. So it is a complete binary tree. I'll show you one example where the tree is not a complete binary tree. Like this example. First we'll check all the levels are filled above the last level. Yes, it is filled. But when we see the last level, the filling should be done from here. That's this node should have two nodes, then this node should have two nodes, and after that this node should have two nodes. But the filling is there are missing four nodes over here. So this is not a complete binary tree. Okay, I hope you understand. If not, you can check my first video, my first or second video, where I told about the complete types of binary tree. Okay, so now we'll proceed. So I'll solve this question in two parts, and this is the first part where I'll solve it using BFS, breadth first search. For this BFS, if you don't know about BFS, you can check my level order traversal video. I told regarding BFS in that video. Now we'll proceed by solving this question. So I have this example. Before starting with the code, I want to tell you that how this approach can click in our mind that we should use this approach. Okay, to continue with this question, a question might arise that in BFS I'll use Q, but what condition should I write? It says a complete tree, that is all the nodes above should be filled, and in the last level the filling should be done from left side. Okay, now first let's traverse this tree. This node, okay, it has two nodes. Yes, it does have. Then I'm going level wise. Now I'll come up to this node. It has two nodes. Okay, now in this node it has two nodes. Okay, till now everything is correct. Now in the another level I'll come up to this node. This node has two nodes. Yes, and this node, let me change the tree, okay, a bit. Okay, now this node has two nodes. Okay, till this we have completed. Now for this level, that is level 0, level 1 and level 2, I'll draw the Q over here. For this node I have two nodes. I'll name it as 1 and 2, and this is 3 and 4. I'll push this 1 in the queue. This node also has a right, so I'll push 2 in the queue. Now coming to this node has null as left and null as right, so I'll push null in this and null again. Okay, now this node also has null at right and null at left, so I'll put null 2 times. Okay, now talking about this node has 3 and 4. Now coming up to the last level, we can see that it is not a right now this is not a complete binary tree. But how to determine? Now this is the crucial step. That is, we can always determine a tree using queue in the last level. That is, we are having a queue. Okay, now I'll pop out this one. Okay, I'll pop out this one, and let me draw the queue once again to make it a bit longer. I've popped out to one. Okay, 2, then I have null, then once again null, 3, and then 4. I've popped out 1. Does 1 at left or right? No, it does not. So I'll push null and null. Okay. Now, talking about this node, does this has any left or right? No, it does not. So I'll push null and null again. I popped out 2. Now coming to this null, I'll pop out. I'll check, is this null? Yes, it is. So I'll have a flag variable, a boolean flag variable. If I'll encounter a null, I'll set this flag as true. Okay, I'll set this flag as true. I've got null, I'll push it out. Okay, then I'll again get a null and check, is it true? Okay, is it true? Okay, I'll make it true. If it is already true, I'll ignore it. Again null. So I'll pop out all the nulls. Now I'll get a null node. Okay, I'll pop it out. 3. Before proceeding, I will check, is flag true? That means, is a null has come before a null node? Yes, it has come. So now I will return false. I will return false, that no, this is not a complete binary tree. I hope you get the approach, the idea how we will proceed. That in this tree, all the nulls should come after all the null nodes. That is, if any null comes before a node which is not null, that means it is not a complete binary tree. Now I'll extend this. Now let us remove this nodes. Let us think that this is our original tree. Ignore this 2 nodes. Okay, this is our original tree. Now with this, for this node, I'll again make a queue over here. Okay, I'll again make a queue. For this, it has 1 and 2. For this node, it has null and null, as well as for this node null and null, this node null and null. Okay, null and null. Now for this, I come at the last level. I'll pop out 1, check, does it has left or right? No. So I'll push 2 null over here. Okay, then I'll push this. I'll put again 2 null over here. Now I will get null. I will set flag as true. I'll again pop out null and check, is it null? Yes, it is. Is it true? Yes, it is true. So I will not change anything. It will remain as true. Similarly, I'll pop all the nulls, and last what I get, I find that the queue is empty. Now at the queue is empty, so I'll come out of that while loop, in the BFS. At last I will return true, that yes, it is a complete binary tree. So the idea that we get with this approach is that, I'll star mark it, that no null should come before not null node. This is a very important idea that we will be proceeding, that no null should come before not null node. Okay, now I will write the code and explain you step by step, then we'll do a dry run. Okay, so the question is asking the return type should be boolean. So I'll make a function boolean and name this function as solve. The parameter we are getting is the root of the tree, node root. Okay, for BFS, I'll again write over here, this is a BFS approach. Okay, I'll make a queue of node, queue equals to new, and I'll initialize it. Now I will initialize it with this root queue.offer, that is, I'm adding root into this. Okay, now as I told, I will having a flag variable, boolean flag. Initially I will set as false, because we don't have any we don't have any we don't have any null initially. So till when we will be executing? Till the queue does not get empty. Okay, now as I told, we will be going level by level. So now what I'll do, I'll pop out a node. Sorry, it is not tree node, it is node. Class is node. Okay, node, like the node equals to queue.poll. I'm popping out of this queue. I popped out. Okay, and I'll check if this node is equals to null. If this node is equal to null, so I will set flag equal to true. I'll set flag equal to true, and rest I will not do anything. I will not check for its left or right, because null does not have its left or right. Okay, so I'll write continue. Don't do anything further now. And now what I'll do, I'll again check one condition. What condition? Like for example, if it is a null, it will not proceed further. But what if it is a not null? Then the code will come to this condition. And as I said, that all the null should not be coming before a not null. So if a null node is present before a not null node, so I'll check it over here, that if flag is equal to true, then return false. I'll add a comment over here, not null node checks this, because if a node is null, I wrote continue, the code will not come over here, it will again come back here. Okay, if a node is not null, then only in that case the node will come over here in this statement. Now it will check if it is already true, that is a null has occurred before, in that case return false. Now if this doesn't work, that is a null node is not present before a not null node, then check for its left and right. If node dot left is not null, then add it in the queue dot offer node dot left. Similarly, sorry, not null, I would not check the condition, because I'm also adding the null value inside the queue, so I'll not check this not null condition. I'll simply add left and right, because I told that if I would write this condition, I would not hit this condition, right, this null condition. So I will simply add the left and right respective, like whether they are not null or null. Okay, for this I end this while loop, and after that, like if it is a complete binary tree, only then in that case the queue will get empty, and at last I will return true, that yes, it is a complete binary tree. Now I will end this function over here. Okay, so this is the entire code for checking the completeness of a binary tree in BFS. Now we will do a dry run of this. Okay, so this is an example. By seeing it, I can clearly say that yes, it is a complete binary tree. But we will do a dry run, step by step, line by line. So for that, I'll make a queue initially. Okay, I'll make a queue initially. Let us make a queue. Sorry, a bigger queue. Bigger queue. Okay, so now I'll name all them 1 2 3 4 5 6 7 8 and 9, right? Now for this I will initially add queue dot offer root, so I will add 1 in this queue, right? Now we'll check while this is not empty, node equals to node dot poll. I will pop out this. Okay, check, is this one, I have popped out 1, is this 1 or null? No, it is not, so it will come over here. Initially I'll set flag as false. Initially the flag is false, So is flag is true? No, it was not satisfy. What? Add left and right. So the left of 1 is 2, right of 1 is 7. Added. Okay, added, right? Now code will again come over here. Pop the first. Okay, I will pop 2. Good. Is node is null? Is 2 a null? No, 2 is not a null. Then check if flag is true. No, flag is still false. Now do what? Add left and right of 2. 2 left right. Adding left is 3, adding right is 5. Okay, done. This is done. Now code again comes over here. Pop out the first element. Popping out 7. 7 is not null. Okay, not null. Flag true? No, flag is still false. Do what? Add left and add right. Adding, we popped out 7, right? We popped out 7. So adding left 8 and 9. Adding left, then adding right in the queue. Okay. Now code again comes over here. Pop out the first element. Popping out 3. 3 is not null, so it will not satisfy this condition. Flag is still false, not satisfy. Add left and right. 3 having 4 and 6 as left right. Adding left, adding right in the queue. Okay. Now code again comes over here. Pop out the first element. 5 is not null, flag is still false. Add left and right. 5 having null as left, null as right. Okay. Now do what? Again code comes over here. Pop out this element. 8 having 8 is not null, flag is still false. Add left and right. And 8 is having null as both left and right. Pop out 9. 9 is not null, flag is still false. You can see. Add left and right. 9 having null and null in left and right both. Okay. 4 comes 4 over here. 4, pop out 4. 4 is not null, flag is still false. Now add left and right. 4 having null and null as left and right. Pop out 6. 6, this is 6. 6 is not null, flag is still false. Add left and right. Adding left and right. 6 having null and null in both. Okay. Now pop out this another node. Now this is null. If node is null, yes, it is null. So now set flag as true. Okay, set flag as true. Continue. That code again comes over here. Pop out element. Again pop out element. This is null. Yes, it is null. Flag equals to true. It is true. Okay, so don't modify, don't change. Continue. Again, you can see over here the code is coming again and again. It is looping over here till the code is till this queue is not getting emptied, because all the nodes here are null. You can see, right? Null. So here at last the queue will become empty. The queue will become empty, and this will not satisfy this condition, so it will come out of this while loop and it will return true that it is a complete binary tree. And we can also see that yes, it is a complete binary tree. So hence we did a dry run and clearly understand this question. If still you have any doubt, you can drop it in the comment box. Thank you for watching.